Section 5.4 The graph of rational function. Example number 1. We want to graph the rational function r of x equal x minus 1 divided by x squared minus 4. We're gonna follow the following steps. Step number 1, we need to find the domain. You look in the bottom and you see that if x equal plus minus 2, then we will get the function is undefined. So the domain of r of x is all real number except for x equal plus minus 2. We need to factor the r of x. R of x equal x minus 1 divided by x squared minus 4. We factor the top, and the top we cannot factor. We factor the bottom. You look at the top and the bottom, we do not have the margin parentheses to cancel. So r of x is already in the lowest term. You notice that r of x have two forms, lowest form and the factor form. So we're gonna use either form later to plug in the points, to make more points to find the points in the table. The next step is we need to find the vertical asymptote. The denominator, we will set it equal to 0. Then x equal to plus minus 2. So I will make the graph at the same time. For the vertical and horizontal asymptote, we will need to make the dashed line. Okay, so for the vertical asymptote is x equal to 2 and negative 2. For the horizontal asymptote, we need to look at the degree. The degree on the top is, which is n is 1. The exponent of the x is 1 on the top, the highest exponent. And the exponent in the bottom is 2 because you see x squared. So when n less than m, the horizontal asymptote is y equal to 0. You recall that we either have horizontal asymptote or the oblique asymptote. So when we have the horizontal asymptote, it means that we do not have the oblique asymptote. The horizontal asymptote is y equal to 0, and y equal to 0 is the x-axis. Okay, so we want to find the special points. The special points are the intercepts. We have two kinds of intercept, X-intercept and Y intercept. To find X-intercept, we will let y equal to 0. Y is r of x, so we will let r of x equal to 0. You recall that r of x is x minus 1 divided by x squared minus 4 equal to 0. For the fraction to be 0, the top have to be 0. So x minus 1 equal to 0 and x equal to 1. X-intercept, it means this point is the point on x. So I make the points, I make the red color. So 1 on x. And then to find the y-intercept, we will let x equal to 0. That means we will input 0 into the function. So we get 0 minus 1 over 0 squared minus 4. So negative 1 over negative 4. So we got 1 over 4, which is 0.25. So 0.25 is the point on y. they are the two special points. We need to make additional points to complete this graph. The way to do this is that we will make points in the between of the vertical asymptote and the points. What do I mean by that? We will make the points in this interval. We will make the point in this interval between the red point and the asymptote, the X-intercept, okay? And then we will make this point between that X-intercept and the vertical X equal 2, and we will make this. That means we will have 4 additional points. Now let's work on the one on the left, the smallest one. So from this interval, we will make like x equal to -3, and we will input into the order of x. We can input either in the factor form or the original form. I will input into the original form. So we have -4/5. You use the calculator, you will get -0.8. And -3, -0.8 is like this. So you know that the point, the graph will pass through this point and will approach close to the y-axis and approach close to the x-axis. So we're gonna make more points on that. So how the graph will look like when it's approached to the x-axis. The x-axis that we have in this case is -2, because from this point to the closest x-axis is -2. We will make the point on this side, which is -2.1. So we make -2.1, we will get -2.1 minus 1 divided by -2.1 square minus 4. So -3.1 divided by 2.1 times 2.1 is 4.41, and we minus 4 in the bottom, we got 0.41. So 3.1 divided by 0.41, you got the answer is 7.6. So -2.1, -7.6. If you block that point is somewhere over here in the bottom, right? So you don't have to do that. What do you need to do is you just draw the graph from that point, approach to the X-intercept, close like this, and then you draw the arrow, okay? And then you can make more points, like -4, -5 to see what happened, but you can draw the line that approach to the y-axis, because the graph is always approach to the x-axis and y-axis. So we're done with that interval. Now we're gonna make the interval from this point to that point, but we already have the y-intercept. So basically you just connect this, okay? And then we want to make the points that close to the -2, but on the other side. That means we will make some points around here, that is -1.9, okay? -1.9. Then -1.9 minus 1 divided by -1.9 square minus 4. In the bottom, you get negative 0.39, and then we divide. So you got the answer is 7.4. So where is the negative 1.9, 7.4? So that point from the graph is somewhere here. So you don't have to graph the points because 7.4 compared with your data in this situation is far away. So what do? Is you just draw the curve approach to the X asymptote. Okay, the vertical asymptote, like that. And then now we work on the X equal to. We need to make the points that near 2. Near 2, that means we will make 1.9 on the left and 2.1 on the right. $1.9 on the left and 2.1 on the right. Now we plug into the order of X. So 1.9 minus 1, 1.9 squared minus 4. We got the answer is negative 2.3. 1.9 comma negative 2.3. If you block that point is somewhere right here. So what do? Is you just connect to this and you just draw its approach to the vertical asymptote. Now the other side, you will make 2.1. So 2.1 minus 1, 2.1 square minus 4. So in the bottom you get 0.41. On the top is 1.1. 1.1 divided by 0.41, you will get 2.68, which is 2.7. So 2.1 and 2.7, that point is somewhere here. So remember, we need to make one more point on the other side. So we need to make 3, the nice points. So if X equal to 3, then 3 minus 1, 3 squared minus 4. So 2 divided by 9 minus 4 is 5. So 0.4. 3, 0.4. So from that point 3, 0.4, you can connect to the red point so that you can have the curve approach to the vertical asymptote X equal to 2. And of course, from that point, you can draw the curve that approach to the horizontal asymptote. And we complete the graph. This is the basic points, additional points that we make for this table. And of course, the more points you make, the better graph that you will get. You notice that this graph is just approximate. To make a best graph, you need to make a lot of points. But so far, the problem only want us to do some kind of approximation, not to be so exactly, not to be too perfect.